In this video, we're going to talk about multiplying matrices by a scalar. A couple things to know is just that a matrix is a set of data organized into rows and columns. So it's just a set of numbers organized in a particular way. We could have something like 1, 2, 3, and 4. This would be a 2 by 2 matrix. Or we could have a 2 by 3 matrix where we had numbers something like this. That's what a matrix is. And a scalar is just a real number. And we use the letter k to represent this, but a scalar could be anything from 1 to 5 to 277. A scalar is just a real number in matrix algebra. Now, if we were asked to multiply this 2 by 2 matrix by this scalar of 3, what we would need to do is distribute this 3 to each of the separate numbers in this matrix already. So why don't we go ahead and do that? I'm going to start my matrix here, and let's do our first value, which would be 3 times 6, and that's 18. Our second one, let's do 3 times 4, which would be 12. Next, let's do 3 times 2, 6, and 3 times 5, 15. And that's how we multiply a matrix by a scalar. So that process seems pretty straightforward, but now we're going to look at what we call the distributive property of scalar multiplication. We use this property when we're presented with a kind of situation like this. Here we have two 2 by 2 matrices being added together, and all that whole quantity is being multiplied by a scalar of 4. And there's two ways of evaluating an expression like this. We're going to start by doing it one way, and then I'll show you how to do it the other way. But what we're going to do this time is we're going to take this 4 and we're going to distribute it to both of these matrices in this whole sum. So we would get 4 times this first matrix, -3, 2, -6, 1, plus, and distribute the 4 to the second matrix, 4 times 7, -1, 5, 0. So now we need to multiply that 4 through each of these 2 by 2 matrices. And when we do that, we get, well, 4 times -3 is -12, 4 times 2 is 8, 4 times -6 is -24, 4 times 1 is 4. Okay, and we're still adding it to the second one, so let's multiply this 4 through this 2 by 2 matrix. Well, 4 times 7 is 28, 4 times -1 is -4, 4 times 5 is 20, and 4 times 0 is 0. And to finish evaluating this expression, all we need to do is just add these two matrices together, and we need to remember our rules about matrix addition, where we always add the numbers that are kind of in the same location of the matrices. So we're going to start by adding -12 and 28, and we get 16, and 8 plus -4 is 4. -24 plus 20 is -4, and 4 plus 0 is 4. And that's our answer. Now, a different way we could go about this problem is we could do our addition that's inside these parentheses first, do our matrix addition first, and then distribute our 4 to the resulting 2 by 2 matrix. So let's try that. By adding those two matrices inside the parentheses, we get, well, -3 plus 7 is 4, 2 plus -1 is 1, -6 plus 5 is -1, and 1 plus 0 is 1. So let's not forget that this sum is all being multiplied by this scalar of 4. So let's multiply that through to get our final answer. We have 4 times 4 is 16, 4 times 1 is 4, 4 times -1 is -4, and 4 times 1 is 4. And this matrix is the same matrix that we got when we distributed the 4 to both of the matrices first and then added. So it's acceptable to do it either way.